All right, so the first question we have here is to run a Java file through the command line, we use these commands. Is that true or false?
Yeah, I believe that's true. Wait, I think it's the other way around. So you would compile first, then you will be able to run the file.
Right, yeah,
So I guess
that's
false.
Yeah, it's false, yeah, exactly. Because you have to compile before you run. And to compile, it would be like Java C file.java. And otherwise it'd just be Java file.
Yeah.
Mhm.
Yeah.
Nice.
I know like Python, you can just do Python in the file name without like the extension.
Yeah.
.py, like, but I guess with Java you have to specify whether or not it's Java or not.
Yep. But awesome, yeah, that's exactly right. Okay. So yeah, I guess we get the next one. So true or false, all programming languages should follow, all programming languages follow object-oriented principles.
I feel like that's too general.
Oh, hey everyone. Yeah. Sorry, I was gonna go to the classroom today, and then I'm working on a project all day, and I completely forgot what time it was, and I was like, oh shoot, it's 3. So.
No, I had an epic entrance. I was gonna play the final countdown for y'all.
Oh no! Oh, that's right. We sent a count. Oh.
Yeah, I was like, it's the last class, and I was like,
yeah. Oh man. Oh well. Well, anyway, welcome. Yeah. So okay. So we're on question 2. So question 1, we went over was, is this how you compile and run? Basically, is to run Java file. And the answer we established was not quite, because it would be Java C file.java to compile, and then Java file without the C here to run. Right? But okay. Now, how about this question? Does anyone know?
False.
Yeah, that's great.
Yeah. Oh, yeah, because like a language doesn't have object-oriented like styles in the language, so I guess it would be false, like Amanda said. That makes sense.
Yeah, a lot of other languages don't have object-oriented. That's great. Yep, nice. Right. So what are the 4 components of a computer?
Survey says memory. I think memory is one. Storage, maybe? No, I don't know. It's in my notes, actually. JK. Wow.
So I would guess it's like the CPU, and then the memory or RAM, and then storage, like Amanda said. And the fourth, I mean, what's the graphics card, but not all computers need a graphics card. I'm not sure what the fourth one is.
Is it input, storage, processing, and output? I don't think.
Yep, that's it. Yeah. So it's I/O, and then storage and memory are one and the same. So yeah. And processing is CPU. So yeah.
Oh, why did you say it's this one? Sorry.
All right. So yeah, let's go to the next question. So what's going to be printed by this code?
One. No, wait. 12 divided by 9 is 1. And then 1. Yep. 1. Yeah, 1 final answer. What is 1?
0.
Yeah.
0.
Let's do Jeopardy. What is 1?
A number. Yeah. Yeah, this looks like 1, because you get 1 and 0. Awesome.
Let's go. Let's go.
All right, so now question 2. Wait, I guess this is another question too, but okay.
Variable names.
Yeah.
It's not new, it's not private.
C can count words can be it.
Yeah.
String can't. I don't
Can H cannot.
H.
You can start with
a number.
Right.
So technically, I don't think, is D valid? I don't think it is it? Because of the exclamation point?
Yeah, it's not. That's right.
Okay.
So C, E, and F.
That looks right.
C.
Yeah.
But technically, I shouldn't like. You shouldn't write unless like it's for. Yeah, for a verb, it's better if you don't write or F, but it's still legal.
Yeah, well, I can-
Yep. Awesome. Yeah. So CE and nice. Okay.
Wait, was it CE and F or just CE?
Yeah. Oh, it's CE and F. F is also okay.
Yeah.
Oh, okay.
Oh, okay, it's post versus pre, okay.
Yeah.
9-9.
Wait.
Never
9-9.
mind.
I'm gonna go with whatever you think it is.
I'm not. I'm gonna go with whatever you think it is.
I don't think anything.
Because I know it's post, so it's probably
Yes,
doing-
it
it's
goes to the
true,
first
it's
one.
true.
It's true. And
Yeah.
then it,
Yeah. So it'd be after, so since it's after, it won't have to be so. After. Okay, I guess I'll go 9-9.
9-9. Okay.
go
James, you have an answer?
I don't know. It's like I'm thinking because it's post and not pre.
So like the predicament, like just it automatically does it. So I guess it would be 9 and 8.
All right. Well, let's look at this. So we have
I don't know.
var 1 at the beginning, right? Everyone agrees that this is 9, right? 19 divided by 2, 9.
Yeah.
Okay. Then we have var 2 equals var 1. Well, it equals var 1 equals 9. Okay. So basically, if var 1 equals 9, which it does, we do the first thing, right? So we're saying, okay, var 2 is equal to var 1, but then we have post increment. So it's just 9 still, right? For var 2. But the thing is this minus minus still means like var minus minus equals, it is the same as saying like var equals var minus 1.
Yeah.
So we still have to take 1 away from it. So you get 8, 9. Yeah. Like you guys have the right idea. Yeah, it was just like this still does decrement it.
yeah, you got like the verb 2 right, but the 1 you still need to subtract it.
Yeah, I didn't know those. I forgot like how. Because I know like there's a difference between pre and post, and I know at the very end that you subtract it and just take out the end.
So if it was false, verb 1 would decrease and 2 as well, technically.
So wait,
Right.
if it was false,
Okay.
what would it output? Would it output 8 then?
Yeah, for example, if verb 1 was 8, it would actually print 7, 7.
Okay. Well, say what if the statement was var 2 equals var 1 does not equal 9, and so then it would go to false. Then what would it print?
var 2 equals.
Yeah, because verb 1 is 9 and then it decrements 1, so that means 1 is now 8, and then verb 2 is equal to 1, so it's 8. Right?
Wait, no.
Yeah, you're saying if it goes to the false part.
And the second one changes too. Because I thought since it happens after that, or is it because it's in the same one code?
Yeah, it's because it's the same way.
Okay.
Okay. So yeah, next one. So compiler error, yes or no?
Yes, because you don't have anything in variable one yet.
I never initialized variable one, so var1 equals var1 plus 3. There's no var1, so it doesn't work out, like Amanda
Yeah.
said.
Yep. You guys both got it completely right. Yep. Awesome. Okay. How about this next one? Here. Is this a compiler error? Or not?
No.
Yeah, there's not a problem with this. It's perfectly valid. You just set it to 15, then you set it to 2. Okay, how about this one?
It's not initialized.
Yeah, that's right.
That was fast.
You're waiting for that one.
Yeah, that one works. So just cast whatever digit it.
Not a legal variable name though.
Yeah.
So character.
Yeah, so this is like a really tricky one, yeah, because like ordinarily it's fine to add characters like this. Like you can add character because it has a number, right, as a value. But yeah, this variable name is no good. So it's a compiler.
Oh, never mind.
All
You
right,
could repeat it. I'm sorry, I didn't
go on.
see what you said. Was it a compiler or just?
Oh yeah, it is a compiler error because you can't name a variable like this, yeah.
Oh, that's true.
Otherwise it would compile without issue, but it's just the variable name. All right, so yeah. How about this one?
No. Yeah,
Yeah.
it's not algebra. You can't just do variable 4 minus 10 equals 0.
Yeah, that's, I don't know what it would even mean, but yeah, that's right.
Okay, let's see.
No, because it doesn't have a semicolon.
Yeah, no semicolon. There's no like left.
Yeah, but
All of the mathematical
just
equations.
solving it.
Okay,
It's
I'm
not-
sorry.
Secret.
Can I use a calculator? Okay.
And we
6, 12. Wait, okay, no, you can't. So that's the 6. This is 2. Now let's do PEMDAS. This is 13. 13 minus 6
times 6.
is 7. Really? Oh, never mind. 13 times. Oh gosh. 13
Yes,
times. Is that
13
like,
times 6 minus 2. So
is it
13
100?
No, that's you divide it. 130 divided by 2.
8 minus 2
Oh,
sort of.
you gotta do division first and then multiply.
No, I'm just trying to calculate 13 times 6.
Oh. 18, 78.
You see,
78 minus 6. 72.
minus 6?
Oh, I meant 2. Wait, huh? 2. 72 minus 78 minus 76.
Yeah, 76. Yeah.
all right, let's check. Let's check.
Numbers. You're a math major.
I would have paper though.
Okay, so we do parentheses first, right? So that's 6.0 minus 8 over 3 times 27 divided by 2.0. Now we do this because division and multiplication have equal precedence.
Yeah. No, that's not right.
So it's 13.5 times 6 minus 8 over 3. And now we get,
Yeah.
I don't know, 81, I think.
Yeah, yeah, because 6.
What did I want wrong?
Minus
81.
2.
Yeah. No, wow. That's major can do.
Next time. I should
Yeah, Andrew, if there was
Yep.
if it was not never a double, it would have just been 76, right?
Yes, that's right.
Wow.
That's right. Thanks.
Oh, I found 35.
Okay, next one. Now we're on module 2.
Oh no, I'm in module 2. Okay. Three. No. Wait.
2 modulo 6 would just be 2, right?
Three. I think it's, yeah.
Yes.
So
Yeah.
just case 2, which is 3, like you said.
Yep, like Amanda said. Yep.
Okay.
Good job, everyone. That's all got it. It's a tricky question, but it is 2. Or it's 3, sorry. It's case 2, yeah. So it's 3.
Okay. Right there. Oh, the last one, so 4. Yeah, 4. Yeah. Okay. You had to read the question, so I was like, isn't it gonna be the value is 1 from 0, 1, 2, 3, 4? Like,
But
well,
it's a
fine.
range.
Yeah.
Yeah.
That's what I was like, well, I never read the question.
Yeah, the question here should have been, which of these is never printed? And then everyone would have gotten it wrong. But yeah.
So to
We
break,
don't. Yes.
I'm like,
Go ahead.
I don't know. I haven't seen this code in a while, but like the break statement breaks out of the for loop and not the if statement.
Right.
Okay. So it'd just be 4.
Yeah, that's exactly right. Value is 4. Because the last one we go through index is 5.
Yeah.
And we don't.
Yeah. I thought the print statement was in the if statement. I was getting confused because of that.
Oh, yeah.
Yeah.
Awesome. Yep. Okay. So yeah, next question.
Yeah. Would it just be 0, 1, 2, 3, then 4, and then it would skip 5, and it would be 6, 7, 8, 9, and 10.
No, because it would still print 5 though.
I thought it was just.
Oh yeah, it would still print 5. I'm sorry.
The brackets. It only prints 5.
Oh,
and then at
yeah.
the very end, it would print 10.
Yeah.
So wouldn't it just be 5 and 10?
Yeah, this is not pen index. The last one's not inside
Because
of
you
for
gotta
loop.
do the brackets.
Yeah.
Oh, I didn't see the brackets. You guys are right. Yeah, so it would print 5 and 10.
Or is it?
Oh shoot, they're not.
Wait, let's check this. Okay. So yeah, you guys are right. It's outside the brackets, which is kind of tricky, but okay. So it keeps going, right? We have index 0, indexes 1, 2, 3, 4, 5. It finally goes in here, prints, and then we go to continue. So it's just going to jump back to the top of the loop. So that's at 5. Then we have 6. It goes through. 7. It goes through. 8. It goes through. 9. It goes through. 10. It also goes through the loop, right? But then we go back to the top of the loop. We increment index. It's at 11. And then, oh, we don't go through again. And we leave the loop. And index here is 11.
Because it's less than or equal to 10.
Yeah, it's not less than. Right? And if at any point, like I go to the next question too quickly, you guys have a question, just stop me, of course. So, okay. So yeah, it's 1 by 1. Like,
Okay. I was like, false. Wait, shoot, I looked at the wrong one. I looked at the wrong one. I thought it was y. Never mind.
I think the first one is true.
Wait, 5 is not greater than 6, which is false. Correct. Yeah, so true. I thought it was y modulus, and so I was like, okay, so
Oh.
so then I'll take the first one wrong with their names. Yeah, true.
Then second is false. Right?
And 12 minus 7 would be 5. And 5 is not less than 0.
Yeah,
The
yeah.
second one?
The second one.
Not less than 0 also, so to be false for the second one. Um,
And the third one is true.
I don't understand the third one.
yeah, they're only true.
Okay, it's saying false and true.
So that's false.
Okay, and then it's saying
Or-
true and false, which is false, which is true, which is okay. Yeah.
You guys got it. Yeah, all of this right. Yep. Okay. Thanks.
You're welcome. Sorry. And paper.
Yeah. Wait. There you go. Okay. Oh, it's plus 9. Be careful.
Yeah.
Is
So
this
for the first one, it
Would it
goes
be-
straight to continuous. So
would it be
it goes to
25?
yeah.
Okay. Wait.
I heard you, James. Just give him a second and we'll talk. But
We have an answer.
all right, let's see the answer.
25.
25. And that's the same answer James got. And you're all three, you're right. Yeah, that's exactly it.
It only took us like 5 extra minutes.
Yeah, that's okay.
What were you
Okay,
saying?
what's the pattern to it?
Odds. You just add the odds.
That's exactly right.
Yeah, just adding all the odds from range 1 to 10.
Exactly.
Oh no.
Yeah.
I forgot how to do this. It's binary. Okay.
2, 4, 8, 16. All right.
Hmm?
113.
For decimal. No, we have to do octal and hexadecimal.
Oh, never mind. Never mind. We have to like edit the here one too.
I
Um,
just think, yeah, I know.
Can you just write 113 at the top?
I don't have a pen and paper by me, so I'll just leave this one to you guys.
Wow, so much pressure.
But my guess for decimal is 111.
So it's gonna be 1, and then 2, 4, so 6.
This is octal.
Uh-huh.
Okay. And then hexadecimal is just 1, 4.
So it'll be 1,
And then 1 plus 2, 3, 3 plus 4, 7.
or we do 1, 2, 4, okay.
Okay. So for decimal, we got 113.
Okay.
For octal, we got 161. And then for hexadecimal, we got 71.
Okay. So yeah. So this is the binary number, right? So to get it in, I haven't done this, so I'm gonna do it now. To get it into hex, it's just 1 and then 7. Yep. For octal, we can split it into groups of 3, right? So that's 1, 3, 1, 2, 3. And so we have 1, 6, 1. Yep. And then for decimal, okay, it's just 1 plus 2, 4, 8, 16 plus 32 plus 64. Okay. It's 96.
Oh no, my five are
112, 113. Yep. All right, awesome. That's what I got to.
Oh, we're not muted.
Okay. Do I have another one on that? Yeah. So how about this?
Okay, we have come to a conclusion.
All right, what do you get?
For binary, we got 101010.
Yep.
For octal, we got 52. And for hexadecimal, we got 2A.
Yep, that's right. Nice. How did you do it?
Just erased it. Okay. I did like the division. I converted to binary first, and then I just grouped it for octal and hexadecimal.
Awesome. Yeah, so like 42, divide. Nice.
It was $100.
All right, what about this one?
Wait. I'm sorry. Could you
Oh, yeah.
I was
Sure.
still doing it by paper.
Oh, okay.
Like the binary was 101. No, it was 10100. I'm sorry. I'm just gonna type it out.
Okay. Yep, that's right.
And then 52, and then what was the hex? I mean, what was the octal?
Well, 52 is octal, and then hex was 2A.
Okay.
Sometimes with smaller numbers like this, it's easier, even if you like just start with like 16 or something, like base 16, because like 42, you realize pretty quickly, oh, like 56, like 16 squared is way too large. So I only have to worry about 16 to the first. So that's just 2, and then 10 left over. And then you can go to the other 2. But any way that you can get there works. So binary first works.
Okay, thank you.
Okay, so the next one is output of this program.
Did we already do this one before?
Yes, we have.
You can't even see it because like the screen.
Bummer. I drew Bob.
Let's see. How do I?
I finally get them out.
Yeah, because it's great. Yeah.
Yeah, I can't see very well.
Oh, let me show you. I drew Bob.
Oh, cool. I can't see very well, but yeah, it's cool.
And the question is Bob smart? And the answer is James shall find out through computing the problem.
Oh, well, that's true.
On you.
You can just double click. No, on the pen.
Yeah, so is this one a little bit different from the last one, or is it the same one?
I think it's the same, but it might be different.
Okay. For this one, I'm getting 300.
I think that's right. Yeah, if I remember the last one correctly, but I haven't looked at this one very carefully, so let's see.
Yeah, because both student.grade and grades 0 are reference types, and the grade X is a static. So I'm getting 110 plus 100 plus 90, which is 300.
Awesome. Yeah, that's right. Exactly, because when you pass in this grades array or the student object, right? It's, as you said, a reference type. So this is reference, and this is reference. So if you change it, it changes these values. But that's not the case with the grade because it's an int. So great. All right. So
Wait.
yes.
I'm
Yeah. Sorry. Go on.
I didn't hear what they were talking about. I couldn't really hear them. Did they solve it or?
Oh, did you guys solve it? Not sure. Okay. There you go.
Yes,
Okay.
we did. We concluded Bob is smart. Yes.
Awesome.
Yeah.
For the actual value, we got 300.
Yeah.
Oh, okay. Good. Good. I was worried for a second. That works.
Where is this recording going? Just out of curiosity.
It's fun. How is
Shoot, no. Oh. I didn't even know that.
What are you writing?
Right, so this one would be
This looks
D.
like an L. This looks like a D. Wait. This looks like a D. This looks like an L. E-L. I'm so confused. Oh, you're writing cursive. That's fine.
We think it prints world world. I was gonna try to write it, but my cursive sucks.
Oh, okay. Cool. All right. Well, I guess let's go right. We have str1 is hello, right? str2 is world, and then we set str3 equal to str2, and that's world. And then str2 is equal to world again for some reason, and then str1 equals str2. So str1 is world, right? str2 is world, and str3 is world. That's my cursive. That's world right now.
Hey, it's better than mine. Mine spelled it for some reason.
So yeah, we get world.
What did I write? Wild.
I can see a book close enough. I can actually read.
All right, so we're on module 4A now. So data types and strings. So what's the value of var in each of these?
Give me 5 because the doubles cast it after 5.0. Wait, no, oh my gosh, I cannot divide. Oh, no. I can't, 36 divided by 5.
Divided by
6,
7.
7. Yeah, thank you. 7.0 because it's casted after.
Okay, sorry, go ahead.
Yeah, I'm guessing it's 7.0. Like, I think, yeah, because you have 36 and 5, which are both ints.
Yeah.
And then you cast them into a double. So you just add like a 0 once you're done computing them. And you get your answer like that, I think.
So almost. It's not actually quite 7.0 in this case because the thing is, yeah, this double doesn't have.
Yes, there's no parentheses like between or around 36 and 5.
Exactly. Yeah. Yeah. So the casting always just works on the nearest thing. So in this case, and it has higher precedence than like multiplication or division. So we do double 36. So it's now 36.0 divided by 5. And then because one of them is double, we do like type promotion or whatever. I don't know. I think that's what it's called. And then we have 36.0 divided by 5.0, which is 7.2. Hopefully that makes some sense. And we'll go on to the next question, I guess. How about this one? James, you know this one?
Yeah, 7.0.
Yeah, that's exactly right.
Yeah.
And then Raphael, this one, you get?
7.9.
Right, yeah. How about this one?
7 point, no, whatever 36 is.
7.2 again.
Yep, that's right. Means again, we just cast this one, so both get the data type. Don't. Right. All right, now let's go one by one. So what about the first one?
I'm just thinking whether or not the if it's capitalized or not, whether the case matters. I think it matters since they all have different ASCII numbers. So I would say false.
Yeah, that's right. And also, it's asking if word contains message, right? And word is, yeah.
Would have been false the way I was explaining it, or no?
Yes, it would have been false that way too.
Oh, okay.
All right, so false. Now, what does everyone think about the second one?
So yeah. So you would get good and the space with it.
All right, well, we can, so one thing about substring.
Oh, terminating to 4, okay. So
well, yeah.
Good.
Yeah, the way I usually like to think about substring is it starts at the start index, and then you get however many characters is end index minus start index. So in this case, we get 4 minus 0 characters, and we start at character 0. So it's just good, right?
It's going to be a 0. Substring doesn't give out true or false.
No, I know, but I thought it was like asking for this. Oh, wait a minute. Oh my gosh, I was combining both of them.
Yeah.
Like if that was the same info. Like I thought I was saying there's message dot substring for equal to word, but that's what I was doing in my head.
It wouldn't be because it's capitalized.
Yeah, so okay. I think 2 is true.
This one.
Oh, yeah. It goes with the O's. I mean, it's not the exact same.
Yeah. Both of the characters are O, so it would be true.
Yep, that's okay. Both groups got it. Yeah, awesome. Yeah, it's we have O and O. Yeah.
That'll be -1.
-1.
Awesome.
It's not found in Word, so
Okay, yeah.
Yep.
I can hear them. Are you able to hear them, Andrew?
Yeah, I can hear them.
I'll just turn up my volume.
Yeah.
So the index would be 0.
Oh, it's a word, right? So you already.
Oh, never mind. It would be false. Or would you get a compile error or just be false?
It doesn't give an error. It just returns -1 if it doesn't have it.
Oh, -1. Okay.
Yep. What about this last one? What does everyone think?
That should be true.
I think so, yeah.
Yeah, that would be true.
Yep. Yeah, of course. Yeah, because good luck. Their case. Good luck. Yeah. All right. So next one.
For the value of pi, 3.14, and the second one would be value of pi of 15.
Isn't it technically, since it's a static variable, you can't change it?
Oh, it is.
But I'm not sure. Maybe you're right.
Yeah, I was looking at the static.
I don't know.
You can change static variables, you just can't change final variables.
I know. Okay. Oh, okay. So if you did have public static final double,
Right.
okay. Yeah, like it would be just like you said.
Yeah, 3.14 and 13.14.
Yep. Exactly. Nice. Because you have 3.14 here, and you just add 10 to it.
So it'd just be 3.14 and then 13.14.
That's good. Great.
Okay.
Yeah.
What about this one?
Final.
Would you get a compile error since it's a constant, since pi is a constant?
Mm-hmm. Yeah, that's right. So it's error, right? Because it's final, and we try and modify it, which we can't do. All right, now on to the next module, which is arrays, 4b. So what does this one output?
Oh, this is like one of the test questions.
So would it just be A, since we made a new array for the variable A and we left B the previous as the previous variable of A, I mean previous array of A. That makes sense.
Yeah. That's right. Yeah, nice. So going over it, right? How we have A is, it points to this, right? 11, 22, 10, 8. And then B is equal to A. So B just points to the same thing. And so now we have A equals new in. So because we use the new keyword right now, A no longer points to this, now points to this. So when we set A of 3 equal to 2, that changes the new A, right, to 2. And so when we print all the elements of B, it's just going to print all the elements of B, which are completely unchanged. Right, so it's this.
Okay.
Yeah, just like you said. Makes sense to, yes, Amanda, Raphael.
Yes.
Awesome. Okay.
Okay. A.
Or should that be A?
I don't see anything like that. You don't want to move stop running. Yeah. Unless you're doing it doesn't have to. Wait, major, yeah, no.
Yeah, like that.
Yeah, so would it just be A, since both of the matrices are pointing to the same reference in the memory, or no?
Yeah, it was already there. Yeah, exactly. So Amanda and Rafaela, what do you guys get?
Oh, we got A, yeah.
Okay, awesome.
Yeah, you said it a
yeah.
while ago.
I guess, yeah, I guess.
Oh, okay, sorry. So yeah, so just like that, right? We have like 4 arrays, and the first one we set to length 2, right? And we then say, okay, this one's also equal to that. And this one's 0th element is that, and this one's first element is, oh, sorry, 0th element is 3, not 0. And first element is 4. And so when we print it, it's just 3, 4. Okay. What are these?
Ruby false true. Okay.
So yeah, it would be false and true.
Yep. So everyone got it right. So can someone tell me why it's false true?
Yeah, everyone is not, it doesn't reference the same thing as array 2, but they have the same values as I. That's why the boolean is the same, stays true. So it's very important.
Yeah, awesome. That's right.
45? I mean,
Wait,
wait,
yeah.
22.
So you guys got 64 and you guys divided it by 2.
We got 45.
Oh, never mind.
Because we
I was doing it in my head and I kind of lost track of the numbers, so
what we did was we did
I'll leave this one to you guys.
Yeah, the one thing we're unsure about was the post versus pre-increment, but when we summed it up, we just did the 3 for each one, like the first 3 of each row. And so when you do that, you get 45, and then we did 45 divided by 2, which is 22.5, but it's sum is an int, so it's just 22.
Yep, that's exactly right. Yeah, because you have like 1, 2, 3, 4, right? Like you just said, 5, 6, 7, 7, 8, 9, 10, 10, 11,
Okay.
12, and 14. So we're only concerned with like the triangle or the rectangle, square. I know my shapes here, which is just summing 1 through 9, which is like 1 plus 9, or no, sorry, 9 times 9 plus 1 over 2, I think. Yeah. And then that, oh, okay. Well, we don't even have to use that. You could just sum them. But then we do sum divided by 2. So we have 45 over 2, 22. Cool. All right. So
Yes to A, I mean true.
mhm.
I think B is subjective, but I would say false. Because I mean, it depends on the person, like ethics.
So if it depends on the person, then it's person.
Well, yeah, but at the same time, but there's like a code, like there's a
Yes,
like a
there
world,
is
there's like a
code
word, there's
already
like a
defined
there's
for
like
the
a
text.
statement, but like how people interpret it individually can vary. So that's why I'm like yes and no, true and false.
Okay, well, if you were to be given a question like this, what would you think we would want the answer to be?
I want the answer to be false,
Yes.
but
I would say false. No. But we all know what's good and bad, and you know it's pretty general, and people know what's good and people know what's bad. Ethics is like more of like good behavior, so I would go with false. I don't think it's personal, since everyone knows the difference between good and bad. You know.
Yeah, this one's kind of a gray area question. The answer is like technically it's true because like it do tend to be a little personal, but like I'm pretty sure anyway. But yeah, this one does fall a little bit into like gray area, so I can see both sides.
On the final exam, would this one be true or false?
I think this is actually on the final review, but I think yeah, I'm pretty sure it says true.
Okay.
The next one,
I think it's true.
I mean, I feel like these are all subjective.
Yeah, but like if you think about it, you need, I don't know.
Like they have a legal like law about like coding, like taking
Okay, so
legal components.
Exactly.
Does that like answer the question that is at hand?
this one to me seems a little bit I guess kind of less gray because like okay, are ethics based on legality or like is legality based on ethics?
Yes, that's second.
Yeah, exactly. So ethics aren't really based on legality, right? Like we have ethics and like laws are passed around them, but
yeah.
ethics existed like way before laws. So, well, I mean, I don't really know. I wasn't around then. So, yeah. So they're not based on legality, right? And D.
D is true.
True.
Yes, true.
And E.
True.
True.
Awesome. Okay. Yeah. Yes. What about this?
Yeah, you would use pull.
Yeah.
Exactly, right. Because like you have your repository here, you have your code here. Someone made some changes, right? You want the changes, you have to pull them, like, pull them onto your computer, right? So, yep.
D, that's a reason.
Yeah, D.
Yeah.
Doesn't even sound right.
Hmm. Yeah, I'm guessing. Wait.
It's
Yeah, I'm pretty sure there's like a exception for dividing by 0. So I'm guessing exception generated for exception E.
Yeah. That's right. Yeah. I mean this question I guess takes knowing that this kind of error is an error exception. Oh, there is an exception for after 0, and that exception is not this one, right?
Yeah.
Yeah. I think it's an arithmetic exception. Yeah. So yep, difference exception generated. Okay, next one.
Yeah. Yeah, you would do set. So it would be D.
All right. Amanda, Rafaela, what do you guys think?
So there's the get and set. The getter function would be end. The setter of the void.
I'm sorry, you said something?
yeah, void.
Oh yeah, it is void. Yep. Nice job, everyone. Yeah, this is void. This doesn't return anything, right? You're just setting something.
The second one, yes, for the first one, which one is it?
Int, or wait, whatever it is.
Yeah, for the switched on, I guess you would do Boolean. And then for the wait, I'm sorry. And the setter would be the getter would be Boolean and the setter would be void.
Exactly. Yep. Let's see. I'll draw a line between like two classes.
Yeah, so you would just do you'll get name null and your grade will be 0. Because for each setter there's no this or statement or anything, so it doesn't know where to get the grade or what to set the grade to.
Mhm.
It would need the this dot grade and this dot name, right?
Yeah, you would need those to differentiate. Like, if you don't have them, it's just going to be default type of string, default type of int. So
No and zero.
mhm.
Two.
All right. James, do you have anything?
Yeah, you would get 2, I think.
All right. Well, let's look. So we have t-shirt T1 equals new shirt t-shirt, right? So we use the new keyword. Is the only time we ever call the constructor. So we call the constructor because we use the new keyword and call the constructor, right? So here, inside of here, we set size equal to shirt size, and we increase our shirt count. So now shirt count is 1, right? And it's static, right? So we can access it across anything. But t-shirt T2 equals T1. This just creates a reference, right, to T1. It doesn't create a new t-shirt. So we don't call the constructor of the t-shirt class because it doesn't create a new object. It just references the same one as before.
Okay.
So we still have shirt count as 1. So when we do this, we just get 1.
Thanks, Andrew.
You're welcome.
Yeah, Andrew, we have to go. Amanda has a formal later tonight.
Yeah, I have to get ready for it. But y'all are a ray of sunshine, and I draw a sun to show like how like obvious. I'm gonna miss y'all. And it's
Oh,
super
yeah, this is a fun semester. Too bad I missed like the walk-up music, you know.
I was like, I'll just get ready.
Yeah.
But yeah, no. Thank you guys so much for making like a great in-person class.
Yeah.
Bye.
Bye.
I guess. All right, we can keep going if you want. So
Okay. I feel like I'm getting interviewed right now.
no, I don't feel like that. This is just like whatever, you know.
Yeah.
If you don't want to answer a question, even you can be like, yeah, I don't want to do it.
Okay.
So what are your weaknesses?
Oh, so this is just an example of like the super method. So
Yeah.
it's asking us what's the output. So see that move. So we're looking at it would just be super.move, which is vehicle, and then it would print out car. So it would just be vehicle and car.
All right, let's look. So if car C equals new car, so we go to the car class and extends vehicle. You're right, it extends. So we're going to call the vehicles constructor. But okay, that doesn't do anything. So we call super.move right here in move. We call move. Yep. And so it prints vehicle and then it prints car. That's exactly right. Awesome.
Following statements are valid. Oh, okay. Yeah, so A would be valid, right?
A car is a sedan. And that is, yep, that's true. So yep, this is okay.
And then B would be false.
Oh wait, sorry. Did I say it? A car, sorry, sedan extends car. So
Oh, that would be false.
yeah, that's false, sorry.
All right, that one would also be false. Sedan does not extend from vehicle.
Right, yeah.
And
Wait,
C,
sorry. I keep thinking of it backwards too. Okay. No. Well, what we're basically saying is we're going from right to left, right? And we're saying like, is this this? So is a car a sedan? And it's not, right? But is a sedan a vehicle? Like if we draw this out, I guess, yeah, let's draw it out, right? So we have sedan, and above that we have car, and above that we have vehicle, right?
yeah.
So every car is a vehicle, and every sedan is a car.
Yeah. So I'm guessing that one would be true then.
Yeah, right, exactly. Because a sedan is a vehicle, so that's true. This line at least is true. And then
I was just getting confused. I thought vehicle was like the parent of all of them.
oh yeah.
Yeah. Car extends from object. Yeah, that's true. So C would be true.
Yep.
Yeah, sedan extends from car. D would be true.
And then the second part of it.
You're just casting sedan. Yeah, that would work. Yeah.
Yeah, exactly.
And then yeah, car extends from vehicle, so that one would be true.
Yep. Awesome.
Okay.
How about this one?
So the runtime type is animal and the compile time type is dog.
Yeah. The runtime type is. Sorry, say it again. Yeah.
The runtime type is animal and the compiled time type is dog, correct?
It's compile time on the left and runtime on the right.
Oh, yeah, I just got that confused. Animal, okay. Yeah, so dog extends from animal, so it compiles and doggo.print. Yeah, so I guess it would just print out forgot how to do this.
It's okay,
So
we can go over it.
Animal printed because it doesn't have a parameter called name.
Yeah, so okay, so the first thing is, as you said, right, it compiles. That's the first thing we need to check, right? Does it compile? Like, is the thing on the right and like a subclass of thing on the left? And it is, right? And then we have to check, like, okay, can we do this? Doggo.print. Well, doggo at compile time is an animal, right? An animal has that print method. So we're good, right? This completely compiles. Then when it runs, we have to check, oh, okay, we look at the print state, the print, and we check the runtime type because we're at runtime, right? So when the code actually runs, it checks the runtime type. So it's going to look inside the dog class. And it's going to say print here, it's going to say dog printed.
Oh, okay. So if the dog class didn't have like the print method, it would just go to the animal class instead and look for it there.
That's exactly right.
Oh, okay, that makes sense. All right.
And if this weren't here, what do you think will happen?
I don't think it would run at all.
Yeah, it wouldn't compile. Yeah.
Oh, compile, yeah, it wouldn't
Yeah.
compile at all. Yeah. Oh no. Can we go over bubble sort again? I forgot how
Sure.
to do it. Yeah.
Yeah. So bubble sort is the one where in each pass you go through the array, right? And you just keep swapping. Like if this one is larger than this one, you swap. And if it's less, then you don't swap, you just move on to the next. So here, in this case, we have 12, 13, 5, 9, 0. You have 12 less than 13, so you don't swap. 13 is greater than 5, so you swap. So now it's 5, and this one's 13. And then 9 is less than 13, so again, you swap. And 0 is less than 13, so again, you swap.
Yeah.
That's the first pass. And then in the next pass, right, we have to swap 12 and 5. So we have 5, then 12, and then 12 is greater than 9, so they swap as well.
Yeah.
9 and 12, and then 12 and 0 also swap, right? And so that's after 2 passes.
So the 2 passes would be wait. I can't see your handwriting.
Oh, okay.
Can you just never mind.
Sorry, it's 5, 9, 0, 12, 13. So I'll write it more neatly.
Okay. 5, 9, 0, 12, 13. Okay. All right. So like each passes when we go through each element in the array.
Yeah, we go through every like index in the array one time.
Okay. Wait, did we? Yeah, that's the second pass, right? Yeah.
Mhm.
Yeah, I got it.
Awesome. Okay, good.
Insertion sort.
If the insertion sort.
Hmm.
I don't know what that's supposed to mean, but yeah.
Yeah. So it just wants us to use insertion sort for 2 passes. Okay.
Mhm.
It's 0, 5, 12, 13, and 9 for insertion. Because for insertion sort, we're looking for the smallest element, and then we replace the smallest element with the first index of the array.
Oh, that's for selection sort. For insertion, yeah, they're tricky. But for insertion sort, you just in the first pass you sort the first 2 elements. In the second pass, you sort the first 3 elements, and so on.
Oh, okay. All right, so
So-
it would be 12, 5, 13, 9, and 0 for the second one. Or that would be the first one.
That's the first one. Yeah.
Okay. For the second one, it would be 12, 5, 9, 13, and 0.
Okay. So what I mean is okay. The first pass we have 12 and 13, and we sort those, right? And then the rest of the array stays the same. In the second pass, we sort 5, 12, and 13, and the rest of the array stays the same.
Oh, so it would just be 5, 12, 13.
Yep.
9 and 0. Okay, I see now.
Okay, cool.
I was kind of mixing bubble sort and this one together. That's why.
Yeah, I figured.
I forgot to put like the smallest one where it was supposed to be.
Okay, and then yeah, comparing linear and binary search. So how many comparisons? Let's see, to see that this one does or does not exist. 7. Well, for linear search, how many things to check it against?
It would just be 7 elements it would have to check.
For this array?
Oh, never mind. That would be. It'll be 5. Never mind.
Yeah,
5.
okay. So 5. Okay, and then for binary search?
It would be 2 or
I'm
2.
not even sure off the top of my head, but that sounds actually pretty right. So let's see, 50, 90, 100. So first time 50 is the element we check. It's not that, so we cross that off. We have 0 plus 1 over 2 is 0. Yeah, so we cross off that. So it's 2. Yep.
Yeah.
Okay, so big O complexity.
Yes, for this one, it would find it in big O n time, since it's a linear search.
So it is a linear search, that's true. But it's a linear search where this size is defined to be a constant value.
Oh, so it'd just be big O 100.
Right, big O 100, which is also equal to
1.
Yeah,
Or,
that's it.
yeah.
Big O 1. This one's really tricky, but
Yeah, they're probably gonna put like big O 100 on the exam, so I should be aware of that.
yeah, well, yeah, they'd probably just put big O of 1, and then you'd have to put that as your option. But something like this, like, probably can't come up because it's like, oh, it looks like n, but then it's something not because it's a fixed size.
This one, it would be big O n squared, since we have 2 for loops.
What's the outer for loop based on? Like which variable?
Out of for loops based off n.
And the inner one?
Is based off m. So I guess it would be like big O n times m.
Yeah, that's exactly right.
Oh. Okay. So this one would be big O n plus m.
Yep, that's right, because they're separate.
This one would be big O n squared. Wait, yeah. Wait. Doing I and J. So yeah, big O n squared. We're just converting the I and J into n, which is n squared.
Oh, well, you can't quite convert ing to n. So, okay, the outer one is based off of what? Like, how many times does it loop?
It would be 100 times.
100? And how about the inner one?
How many times the inner one moves? So
Yeah.
So would be like 100 factorial, I think.
So, well, it would be like 100 each time, right? So, okay, so like the first time, or let's just assume I is the biggest possible value it ever will be.
Yeah.
Because if we say, oh, it's that, then it'll always be at least maybe less than that or something, right? But it can never be more than this. So if we just assign I to be 100 in the inner loop, right? Instead of I, we say like j less than 100. Then what do we notice? That like if we say I is the biggest possible value, so instead of I, we say 100. Then what is the time complexity of our loop?
So since the biggest number is 100, it'll be constant. So it'll be big O 1.
Yep, exactly. Right.
Okay. So this one would be big O N.
Okay.
So and yeah, it would just be big O N, right?
So the outer one is based off of n, right?
Yeah.
What's the inner one based off of?
Inner one is based off I.
Based off of I. And what is I based off of?
I is based off N.
Mm-hmm.
So it'd be big O N squared.
Yeah. Yeah.
Right, these are so confusing.
They are confusing. I agree. But like it takes a little bit of practice. You just have to like look at it and be like, okay, if it's nested loops, generally you look at the outer one and you're like, okay, what is this based off of? And the inner one, you're like, okay, what is this based off of? And if it's based off of like the previous one, you just base this one off of whatever this is based off of. So
Okay. So this one is big O log N. Wait. So that one's based off of M, and that one's based off of N. Oh, okay, I got it. So this one's big O N times log N M.
yes, that's exactly right. Yep.
Okay.
Go n log m. Yep. Well, I mean, it should be, right? Except like for some reason they have j starting at 0 and j times equals 2, so it's an infinite loop, but assuming m is positive. Yeah, generally you're completely right though. Nice.
Okay.
All right, so what about this one?
This is recursion.
Mhm.
Yeah, I suck at recursion. Can we just go over these?
Yeah, of course.
Yeah.
So, okay, so we have func 4. So we pass in 4 and we say, okay, here we have valid 0. Okay, so let's actually just keep track of our function calls. F of 4. So f of 4, if n is 1, it's not. If n is 0, it's not. So we do else, and we do val equals. So we have to solve these. So we have f of 3 and f of 2. And then we're going to print this, right, at the end. But not yet, because we haven't gotten to it yet, because first we have to do these function calls.
Yeah.
Okay. So we do the one on the left first, right?
Mm-hmm.
And so actually I should have written this at the top. So I'll switch to the top. So f of 4 is f of 3, f of 2. So we do f of 3 first, and that gives us f of 2 and f of 1, right?
Yeah.
Which this one is then f of 1 and f of 0.
Yeah.
And then this one just becomes what?
1 would be 1, and then 0 would be 0.
Right. Yeah. And so the thing is, as soon as this one returns, right, we print it. So we print 1. This one returns, we print 0. So far I have 1, 0. And then we go back up, right, because we've solved everything in the little tree here, right? So we go back up to the top, we go to f of 2. Everything, all of its like, children are done, and we go to f of 3. Now the one on the right isn't done. So we have to do this one. And f of 1, right, is 1. So we just print 1 again.
Yeah.
And we go back up. And then we have f of 2, right?
Which is 1, 0. Okay.
Exactly. And then what do we get?
1, 0, 1, and then 1, 0.
Mm-hmm.
Okay.
Wait, I think. Oh, sorry. I completely missed something in the question. I'm sorry. The thing is that yes, what we've done so far is right, but I forgot that like these calls also have to print their value, not
So-
just like the leaves.
Oh, so are we always going from left to right with the tree?
Yeah, we go left to right. So because the thing is as we go down, right, this is the one we have to compute first.
Yeah. Okay, so this one would be 1, 0, 1, and then 3 would be 1, 0, 1 again.
So sorry, we have 1, 0, and then we have to we solve this one, which is yeah, sorry, that's 1, right? And then we go back up, but we need to solve both of its children first, right? So then we have 1 from this, and then we can solve f of 3. And this one was 1, this one was 1, so this one f of 3 is 2, right?
Oh, okay. So you're just adding them together. Okay.
Exactly. Now, in order to compute f of 4, we need both the left side, which was 2, and the right side. So we
Oh.
solve for the right side. And on the right side, we need to solve the left part first, which is 1, right? And then we go back up, we solve the right part. Oh, first we print it, right? Then we go back up, we do the right part, which is 0, we print it. This is 1 plus 0 is 1.
Yeah.
1.
So f of 4 would be 2 plus 1, which is 3.
Yeah, that's right. Exactly.
Okay. All right, that makes sense.
Cool.
So first we make the tree, then and once we get a value that's returned, we start at the bottom from left to right and we go back up.
And the reason why we're doing that is because we have to always like solve the left one first, right?
Okay.
Then we solve the right. And only once we solve the left and the right do we know this one.
Okay.
So we have one more question, I think, on recursion. Yeah.
All right, I'm just gonna just give me 2 minutes or a minute. I'm just gonna try to write it down and
Yeah, go for it, of
if
course.
I got it right. right. I think I kind of did it wrong. I just summed all of them together. I didn't print each one, but the final answer I got was 44.
Yeah, there's only one print statement here, right? So you only have to print it once. Because
Oh,
the print statement's outside in the main. So let's see. It's if it's 1, you return 1. Otherwise, you return 8 plus m of 7, right? M of 7 is m of 6, or 7 plus m of 6, right? And m of 6 is 6 plus m of 5.
yeah.
Which is 5 plus m of 4, all the way down until you get to 1. So we have 8, 7, 6, 5, 4, 3, 2. And when we get to 1, it's just 1, right? So that's going to be, I think, 36 is what we get. But okay, 8, 7, 6.
Wrong. I kind of did what you did, but instead of doing 8 plus m of 7, I did 8 plus m of 8, and I went so on like that.
Oh, yeah.
So I just eight more, you know.
Makes sense.
That's where I went wrong. What were you gonna say?
Oh, yeah. I don't know. These problems are kind of like actually hard to trace for sure, because you're calling the same function a bunch of times and you have to like draw it out.
Yeah. I'll just practice them a little bit more. I doubt the problems on our exam are gonna deviate away from the ones we have here, so I'm just gonna practice these a whole bunch.
Okay, awesome.
Well, it looks like we're finished.
Yep, I think that's it. So good luck on your exam.
Thanks, Andrew. Thanks for the semester.
Yeah, thank you.
All right. Bye.